The next talk is going to be cloud downtime reduction via firmware updates. I'm going to be joined presenting with Chengen from Tencent. One of the important thing is, if you want to reduce the downtime, I think you saw the one from Microsoft, right? We need to do a runtime update, especially if you are trying to reduce the SLAs, right? So if you are looking at the problem in multiple different ways, right? Why it matters? I think we have a strong case for why it matters. And what are the things can cause downtime? And also, what are the innovations we already put in place to reduce it? And also, we will go through some of the example implementations Tencent has done. So if you look at the IDC reports, if you break down on the total IT operation cost, one of the cost is related to the downtime, other than you have to buy the system and get it operational, and you have other maintenance things going on. But the bigger budget is going on to the downtime. How do we, when you have services are down, sometimes you have to pay some money back, or you are taking some penalties. You are not able to monetize that things, right? And also, if you are looking at the downtime, right? If you are reduce the downtime, you could potentially save some of the TCOs, right? You can probably reduce number of systems that you need to have as an extra system to basically augment your downtime things. And like we said, right, SLAs are another important, right? And also, like if you look at the life cycle of the systems, right, we are going to have BIOS changes throughout the life from the release. You need to update the BIOSes. But if you are not able to shut down your VMs, you are going to keep on postponing the update until the systems is ready to take the updates. And another thing is, you have a system interrupt, SMIs. When you do have a lot of SMIs, it's going to take some system away from your workloads. That also manifests into some of the things that you can notice it. Again, if you look at the firmware downtime, right, it's again an IDC report. On the total things, right, about 10% is hardware related. The remaining 90% is either firmware and all the OS and other upgrades that you are doing. Out of the 100%, 30% is firmware related. So you have 3x of the hardware downtime is caused by the firmware itself. So the main thing is really like you want to solve the problem of how do we able to do a runtime updates so that you can able to reduce the downtime caused by the firmware. If you are able to do alive all the time without any service interruption, you can able to recover that pie back, right? And let us look at the innovations that we are doing. So Intel has put out in our product, right? We added the microcode update. It was there for a long time. We continue to have. And on top of that, all the MEs you can update during runtime. Intel SSD's firmware can be updated at runtime. And also, we introduced the SMM update during runtime. So you can upgrade the SMM drivers or code so that you can able to, you don't need to reboot the system for that. And also for fast recovery, right? If you are even updating the operating system, you may need to reboot in order to get the kernel drivers loaded. So you need to have a fast warm boot time so that you can able to recover it quickly, and also fast services. And also we introduced the PRM, in which platform runtime mechanism. You can offload some of the SMM tasks to the PRM, and you can run in the OS context. And also you can offload some of the work from SMM to BMC, so that you can also reduce the interruption cost during runtime. Then I will hand out to Chengen to give their view of the downtime.
Thanks, Sammy. By the way, this work has originally done by my colleague Eric Lee from Tencent. He could not make the travel, so I just try my best to give you guys the key points, and hopefully Sammy can help me to answer the questions and later after the talk. Okay, so first let's look at the two major challenges from our side, the Tencent Cloud servers. The first one is the long downtime due to the BIOS update, because we need to do the system reset after BIOS update. The second one is we call it productivity loss and bad end user experience due to the jitters from SMI interruption. Most of the SMI interrupts come from the CE handling. So we have the solutions for these two issues. The first one, for the downtime due to the BIOS update, we propose to do the runtime update, firmware update. We can update the firmware modules one by one in runtime. And for the second issue, the performance jitter issues, we trying to do the PRM adoption. So basically, we trying to use CSI interrupter plus the PRM mechanism instead of the traditional SMI interrupts to get rid of the performance jitter. And Tencent Cloud is the first cloud provider company to practice these two solutions to address these key challenges for the better hyperscale cloud deployment. Okay, so first look at the system management mode runtime update. On the left side, we can see that the flow of the SMM driver update. The key point here is that we want to make change to the SM mode code architecture. So you can see Eric put the, according to the evaluation of the code, that may be upgrade transformed into a standalone mode in advance. What does that mean? That means that you need to figure out what kind of the function you want to do the independent update on runtime. So you separate the code architecture into different functional modules, separate from the code base and the database. In that case, you can do the update independently in runtime without impacting other modules. So basically, it's the decoupling work to avoid any correlation on runtime to like interacting or communication among those modules. Okay, by the way, we need to note that there's the first block in the SMM mode is the SMM RTU. Basically, since it's an update, you need to do some signature check to make sure the updated package is valid. So the RTU, I think, means the root of trust can be done in crypto, in hardware or software crypto engine. Okay, so on the right side, we can see the system management mode code injection. That means, so on the left side is an update for some existing code module. So on the right side, you can do code injection. In case you need some hotfix, you want to inject some hotfix, you want to inject a new function. So in that case, you do the system management mode code injection with a piece of code directly into the DRAM. After the check, you accept the package and you exclude the injected code. You run the code to do some hotfix. And after that done, you unload the code, and it's very convenient for our operation. Okay. Then we take a look at the second issue. We are saying that due to the SMI, the inherent defects of the SMI, we have a lot of jitters due to CE handling. So in this case, we have proposed to do the SCI interrupts instead of the SMI. And you know SMI is a SSL-based language, and it's quite slow in BIOS and have limited functions. So basically, we put the PRM table and the PRM option region that's in the DRAM. And we basically put a piece of UEFI code into the DRAM, and we use the CSI interrupt to call that code. And OS can pick up the PRM table to find out the PRM handling entry and do the similar thing as we did in the SMI. So the same interacting with BMC and the OS. So in this case, we can get rid of the SMI and avoid the performance jitters caused by the SMI. And the results are quite good. Right now, we can almost get all of the performance jitters due to the correctable error handling from the SMI interrupts. Okay.
Thank you, Chengen. Thank you for partnering with us. To just a call to actions here, right? So we want to basically like as OCP or OS systems, right? It'll be good to have a community to define some metrics here, so that how many things we need to offload and how much you want to reduce. We can work on those additional details, right? What is the acceptable blackout time? Is it 1 second, 100 millisecond, or 10 millisecond, or even a second or a minute, right? We need to define what is the acceptable blackout time so that you have multiple different solutions you can create. And again, what is the boot time? Warm boot time, cold boot time. Again, for runtime updates, how many things you want to do a runtime update and how much you want to keep it a non-updatable. And also, you need to have an ecosystem. You need to have the firmware ready. You need to have the operating systems ready and all the orchestration ready so that you can go and deploy all these changes that you are making without requiring without service downtime, right?
Okay, that's it.
That's, I think, concludes our presentation. Thank you. If you have any questions, let us know.